Hello and welcome back to my channel. Today's topic is perfect numbers. So we'll see what are perfect numbers, examples of perfect numbers, how to find them, and a proof of how to find them. So let's dive in. So a number for which the sum of all its factors is equal to twice the number is called a perfect number. For example, the number 28 is a perfect number. Its factors are 1, 2, 4, 7, 14, and 28. The sum of the factors is 56, which is twice of 28. So from 1 to 10, we will see all the numbers. So take 4. Its factors are 1, 2, and 4. So 4 is a square number. So 2, 1 or once only we will consider 2. So what is the sum of the factors? Sum of the factors is 7. And what is twice of 4? Twice of 4 is 8. So 7 is not equal to 8. So 4 is not a perfect number. What about 5? Factors of 5 are only 1 and 5 because 5 is a prime number. So sum of the factors is 6. And twice of 5 is 10. So it's not equal to the sum of the factors. So 5 is also not a perfect number. Now take 6. Factors are 1, 2, 3, and 6. Sum of the factors is 1 plus 2 plus 3 plus 6 is 12, which is equal to twice of 6. So by definition, 6 is a perfect number. So is it magic? Like it's happening? How to find perfect numbers? If we want to really find them, should we check them one by one? Should we check each number and their factors and sum and then see whether it is twice the number? No. Let's see how to find them. So before we want to find perfect numbers, we need to understand a group of prime numbers which are of the form 2 to the power n minus 1. So these numbers are a special class of prime numbers called a Mersenne prime, 2 to the power n minus 1 form. If a prime number is of the form 2 to the power n minus 1, then it's a Mersenne prime. So the first Mersenne prime is 2 to the power 2 minus 1, that is 3. The second one is 2 to the power 3 minus 1, that is 7. The third one is 2 to the power 5 minus 1, that is 31. And so on. So there is a relationship between Mersenne prime and perfect numbers. Let's see. So if 2 to the power p minus 1 is a prime, so this is a Mersenne prime, then if we multiply the Mersenne prime with the previous power of 2, like this is a Mersenne prime and this is the previous power of 2, this is 2 to the power p minus 1, so we multiply with 2 to the power p minus 1. So if we multiply this number, this product of a Mersenne prime and the previous power of 2, this product is a perfect number. So if first Mersenne prime, if we multiply 3 with the previous power of 2, because we got 3 by 2 square minus 1. So if we multiply with 2 to the power 1, then that is 6 is a perfect number. Similarly, the second Mersenne prime 7, 7 we got by 2 to the power 3 minus 1. So if we multiply 7 with 2 square, then we get the perfect number, second perfect number. So let's see. Let's prove this. Why this happens? Let's see. So this is a perfect number. We said that this is going to be a perfect number. We saw a few examples also. So let's prove this for all Mersenne prime. If we multiply it with the previous power of 2, then this product is a perfect number. So let us prove it. So first we'll find the factors of this number. So as we all know that factors come in pairs. So the first pair is 1 and the number itself. 1 and the number itself. So the second pair, we take 1, 2 from the right side and we reduce 1, 2 from the perfect number. So we get 2 and 2 to the power p minus 2 into the Mersenne prime. So similarly, if we keep on doing this, then we will have the last pair as all the powers of 2 have come to the left side and the Mersenne prime, which cannot be broken further because it's a prime number, that is in this side. So these are all the factors of this number. So now let's add all the factors. If we add all the factors, these left side 1, 2, till 2 to the power p minus 1, let us take it to one side. Similarly, the right side factors that has the Mersenne prime number, that we'll keep it to the other side because this is a common number for all these factors. So what we will do is we will take this as a common and then we will add the powers of 2. So if we see that the last pair, this coefficient is 1 and then it is 2, then 4, like that till 2 to the power p minus 1. So this is all the right side factors summation and all the left side factors summation is this. So these two are basically same thing because order is different. But these two, if you see the first one is 1, 2, 2 square and the last one is 2 to the power p minus 1. And for this, its order is just changed. Same 1, 2, 2 to the power 2 like that till 2 to the power p minus 1. So we can take this as common. And then we get 1 plus this Mersenne prime. So we cut the ones. Then we get 2 to the power p. So this summation, this is a geometric progression. If you don't know what it is, then also we can find the summation by seeing the pattern. So let us see the pattern. So first is 1 is 2 to the power 0. In fact, any number to the power 0 is 1. So 2 to the power 0 is 1. We can write it as 2 minus 1. Then 1, that is 2 to the power 0 plus 2 to the power 1, that is 3. We can write it as 2 square minus 1. 2 square is 4. 4 minus 1 is 3. Similarly, this also we can write till 2 square. 1 plus 2 square is 7, which we can write as 2 cube minus 1. Then last example, this continues, but we will try to find a pattern here. So 1 plus 2 square plus 2 cube is 15, which is 2 to the power 4 minus 1. So the pattern here is if you keep doing summation of 2 to the power, 2's power, starting from 1 till the nth term, this is called the last term. So the summation will be this last term we have to increase by 1. So 3 becomes 4. So the final summation will be 2 to the power the last term plus 1. That is 3 plus 1 minus 1. This last term is basically we increase the power of the last number, last power of the last 2. So for this example, if you see the last 2's power is 2. So the sum is 2 to the power 3 minus 1. So this pattern we can follow here and we can extrapolate to any power of 2. So this power 2 to the power p minus 1, if we keep on doing powers of 2, if we keep on adding powers of 2, starting from 1, 1 plus 2 square like that till 2 to the power p minus 1. What will be the summation of this? It will be 2 to the power p minus 1. So this is 2 to the power p minus 1 and this is 2 to the power p. So we'll just rearrange this and we take out 1, 2. So we see that this number is same as this number. So what we see is if we add all the factors of this perfect number, then we get twice of the number. So this is a number which we started out with, and when we add all its factors, we get twice of the number itself. So by definition of perfect number, This is this number multiplied, a Mersenne prime number multiplied with the previous power of 2 gives the perfect number. So let's see the examples once again. Let us map the Mersenne prime to the perfect number. The first one is 3 and the first perfect number is 6. The second Mersenne prime is 7 and the second perfect number is 7 multiplied by 4, that is 28. Similarly, we get the third and the fourth perfect number using the Mersenne prime and the formula. So, how did you like today's session? I hope you liked it and thank you very much. Please like, share and subscribe and